Hi, Nine. So I just wanted to go over our lesson from this week in case you weren't on our call. So first off, um, last week we looked at maximizing volume um, of square-based prisms and cylinders. And this week we're going to look at minimizing surface area. So you can hopefully understand why you might want to minimize your surface area. Um, there's a couple of reasons, really. One of the reasons why you might want to minimize your surface area is that often when we're talking about containers that hold like food and drink, if you buy yourself a drink and you're thinking that you want to drink it, you don't want to necessarily have all of the cold to come out of the drink. And so if you think about a package, if you've got like a cold drink, it's going to lose that cold effect is going to escape through the top and the bottom and the sides. And so the less surface area you have, the less that cold or that heat would escape from your product. So it's one reason why you might want to minimize your surface area. You also might want to minimize surface area because if you have if you think about the cost of your product, the less material that you are using, the cheaper it's going to be to make. So that might be another reason why you might want to minimize surface area. So let's go ahead and take a look at it. So I'm going to work you through the square-based prism, and then I'm going to let you work through the cylinder on your own. So we want to compare the surface areas of square-based prisms that have a fixed volume. And so this time, rather than have you do all the calculations, I'm actually going to get you to use Google Sheets. And we're going to put some formulas in, and then it'll automatically calculate the surface area for us, and then we can actually just identify what the dimensions are that produce that. Okay, so first we need to rearrange our volume formula for height because we know that we have a fixed volume. Okay, so our volume formula is volume, right, is going to be equal to, now it's a square-based prism, so typically right, when we're talking about volume, we always look of a prism. It's always the area of the base, and then that gets multiplied by the height. Okay, and so we know that the base is a square, right? Because it's a square-based prism. So whenever we have a square, right, we have two sides. So some people would label these sides as, sorry, we have four sides, but some people would label these sides as B. Other people might label them as S, okay? So if we've labeled them as B, then we know that the area of the base is going to be B squared times H. So that's our formula. And now what we want to do is we want to rearrange it for height. So we want to get height all by itself. Well, we know that this is like B squared times H. We just don't have to write that multiplication in because it's assumed if we don't write an operator that it's a multiplication. So that means that we need to take the B squared to the other side. So to do that, we need to divide both pieces by B squared. Right? So when we do that, we end up with V, or volume, divided by B squared is equal to height. So now we know our height formula. So now we want to actually set up our spreadsheet. And what we are going to do is we know we're going to come up with some side lengths for the square-based prism. Then we can calculate our area. We can use the height formula to calculate our height. We know what our volume is, and then we know that our surface area formula, if you remember our surface area formula, okay, is equal to, well, we'd have two of these in a square-based prism, right? If we think about, whoops, you can't see that. Let me just bring that down a little further. If we think about our prism, okay, if it has a square base, there's two of these, so it's going to be two of these B squareds, right? And then to that, we're going to have 1, 2, and then we're going to have 3 and 4 of these sides that are going to be the exact same, because it's going to be B times H for this one, right? And then this would be B times H, and then this one would be B times H. So it's going to be 4BH. Right? So, and the reason it is because if you think about it, if it was normally length times width as opposed to B times B, then it would be LH, 2 of the LHs plus 2 of the WHs. And in this case, the length and the width are both B. So it's 2 of the BHs plus 2 of the BHs, which is 4BH. Oh, you can't see that either. Okay, so moving along, we want to set up our spreadsheet so that we know that the area of our base is B squared. We know our height is the volume divided by B squared, and then we already know what our volume is, and now we know what our surface area formula is. So we're going to go ahead, and I'm actually going to get you to take a look at or open up your spreadsheet. Okay, so I'm going to open up mine. So here you can see I now have a spreadsheet. And so there's the side lengths, okay? So the area of the base, that's my side length squared. So that's A. So I'm going to go ahead in here. I'm going to do equals. And I want to take this. So it's going to be 1 squared. So I click on this cell. And then to add the squared, I'm just going to do shift and the caret or the symbol above the 6 on your keyboard, and then squared. So now 1 squared is 1. And now if you remember to drag that down so you don't have to copy and paste it every time, you are just going to click on that little box and you can drag down the formula. And let's try that again. Click on the little box and drag down the formula. There we go. So 2 squared is 4, 3 squared is 9, 4 squared is 16. So it all looks like it's working. So now we want to do the height. Well, we know that the height is equal to the volume divided by the area of the base. So again, we put the equals in, and we know the volume is in this cell, so I'm going to click on the volume, and then I want to divide it by the area of the base. And so this is the area of the base, so I'm going to divide it by this cell, and that is going to give me my height. Okay, so again, I can just drag, hover over the square in the corner, hold the mouse down, and then drag. And so now I can see the height for all of those. Okay, and so then to calculate my surface area, well, I said my surface area was going to be 2 of the bases, right? 2 of the area of the bases, so that's going to equal 2. And then I want to multiply that. So 2 times, I'm going to take the area of the base. So I'm just going to click on this cell right here. So 2 times B2. And then my other area I get using the formula 4 times base times height. So it's going to be 4 times, well, the side length of the base is this cell, so it's going to be A1, and then times the height. And so this is the height. And then I can just hit enter. And so now, again, I'm going to go over here and I'm going to drag this all the way down. Okay. And so now I can see that, that it's decreasing, 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 gets to 96, and then it starts to increase again. So this is my minimum. Okay, so when I'm looking at the minimum, I can see that the minimum occurs when the side length is 4, right? And the height is 4. So just make a note of that. So when the side length is 4 and the height is 4, that is going to give me my minimum surface area. So if we think about our rectangular prism, well, if the side lengths are both 4 and the height is 4, then that is going to obviously give us a rectangular prism that is in the shape of a cube. So let's go back and fill in the worksheet, and then we can come back to this. So I've got the worksheet. So I'm going to, so the one that has, so you can fill this in based on what we just saw, but we recognize that the one that has the least surface area is the one where the side length, so again, let's just draw ourselves, right? These are both B, B, and then this would be H. And so when B and H are all 4, then it has the least surface area. So 4 centimeters by 4 centimeters by 4 centimeters. And so then this is a cube. Okay, so the base, or the side of the base, the side length of the base is 4 centimeters, and the height is 4 centimeters. Okay, so then it says, predict the dimensions of a square-based prism with a minimum surface area if the volume is 125 centimeters cubed. Okay, and so in order to be able to do this, right, well, we know that if the length and width and height are all the same, right, so it's a cube, then our volume is going to be B cubed, right? So in this case, if our volume is B cubed and we know that the volume is 125, well, we can easily solve for B. So 125 is B cubed. And so then we can go ahead and move the 3 to the other side. So we do the opposite operation. So the opposite operation of cubing is cube rooting. So we're going to take the cube root of 125. And when we do that, if I just grab my trusty little calculator here, right? So I'm going to do the cube. So for me, I have to write the 3 first, second function, and then the y to the x button, and then 125. So the cube root of 125 is equal to 5. So I expect my dimensions to be 5 times 5 times 5. So that's what I'm expecting, assuming that what I found in the previous question is correct, and the base and the height are going to be equal, or the side length of the base and the height are going to be equal. So let's verify that. So now we're going to go back to the spreadsheet. So I'm going to share the spreadsheet again. So let me go ahead and share that. So all I'm going to do is where I have 64, so here I'm just going to change this to 125. And then once I've got the 125, I can drag this all the way down. And now I can take a look and see if my thing still holds. So is it 5 by 5? So if I look, it's decreasing to 150, and then it starts to increase again. So if I go over here, yeah, my height is 5 and my side length is 5. So I can assume then that if the side length and the height are the same, that I'm going to get a minimum surface area. So so I'm just going to quickly stop sharing that again. So now let's go back. So now it says predict the dimensions of a square-based prism using the minimum surface area if the volume is 300 centimeters cubed. So we can go through that same process, right? Volume is equal to B cubed. 300 is equal to B cubed. The cube root of 300 is equal to B, and then using your calculator, the cube root of 300, and I get 6.694. I'm just going to round it to 1 decimal, so I look after the 6, it's a 9, so that's more than 5, so I round up, so it's going to become 6.7. So 6.7 then is what I think my base is going to be, and what I think my height is going to be. So 6.7 by 6.7 by 6.7. So I'm going to go ahead and use my spreadsheet to see if that's correct. So once more, I'm going to share my screen, pick my spreadsheet. All right, so if I take a look now, I want to change my volume. So let me go ahead and click on the volume, and I now want to change it to 300. Okay, so here I'm gonna drag it down. Whoops. Oh, got the wrong one there. All right, so let's try that again. Just drag that down. Okay, so now I have 300. All right, now all my side lengths right now are whole numbers, okay? But let's say we didn't know it was 6.7 and we were actually trying to figure it out. Well, we would look here and it decreases, 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 increases. Now, our assumption is that the side length and the height have to be the same. Well, my side length is 6 and my height is 8. And here, my side length is 7 and my height is 6. So I know that it has to exist somewhere between 6 and 7. Right? Because even though this gives me the smallest surface area, these two things aren't the same. So I know it can't be a whole number in this case and it has to be a decimal. So what I can do then is I can start to either add to 6, so do like 6.1, 6.2, 6.3, or subtract from 7 and do 6.9, 6.8, 6.7. So I'm going to go ahead and do 6.9, 6.8, 6.7, right? I can just put in a bunch of them, 6.6, 6.5, I'll keep going, 6.4, okay? So now all I need to do is just copy my formulas down again. So I'm gonna do that for each of these. I'm gonna copy that one down. I'm gonna copy this one down. I'm gonna copy this one down. And I'm gonna copy this one down. So you'll notice that even though 7 was small, that 6.9 is smaller, 6.8, 6.7, and then we start to go back up again. And if I look at my height, 6.68, which would round to 6.7, is the same as the side length of my base, which is 6.7. So I have shown using my spreadsheet that the height and the side length of the base are going to be the same. Okay, so the easiest thing to do is once you've kind of narrowed down which whole number is closest to the minimum, then you just start stepping between them by like 0.1s. In future iterations of this kind of math, so when you're not in grade 9 anymore, when you're in grade 12, you're actually going to learn something called derivatives, which is the algebraic way to do all of this, because right now we're doing a lot of guess and checking. So let's go back to our handout. So it says, so we tested it, and it was 6.7 by 6.7, and again, the shape is a cube, okay? So then we've got just a quick summary here. So it says the minimum surface area of a square base prism with a fixed volume occurs when the side lengths of the square base equals the side length of the height. And it's going to be in the shape of a cube. And then this just says to find the dimensions of a square base prism with a minimum surface area for a given volume, solve for the formula volume equals S cubed. So for side length here, they used S instead of the B that I used, but it's the same thing for S. And then we should just say where S is the side length of the base. So for homework, you have to do this for a cylinder. The Google Sheet is on your website, so you can go and find it. And anyway, nines, hope that helped.